Okay, here's FRQ1 from our timed practice last week. Let's see. This is calculator, so make sure you have your calculator handy to go through this with me. All right, the domain of F, here is F, consists of 5 real numbers, 1, 2, 3, 4, 5. So that right there tells me F is not continuous because it literally just has 5 points. So the table defines function F, and then we have function G, which is given by this here. All right, so the function H is defined by H of X equals G of F of X. I want to find the value of H of 1 as a decimal approximation or indicate that it is not defined. All right, so here is my practice booklet here. So what I'm going to do, because I can't flip back and forth very easily, I mean, I can flip it back and forth to show you that, but then I'm going to forget what I just looked at. I'm going to write G of X up here so that I have it handy for myself. G of X equals 0.35 X cubed minus 3.5 X squared plus 11. Okay. Just having that there for myself, you wouldn't have to do that, but since I can't see them both. All right, so the first part said, I want it, so it says H, I want H of 1. So based on what they said, since they told me H is G of F of X, then this is G of F of 1. All right, so I start with F of 1. F of 1 is 6. So that means now I want G of 6. Now, this is a calculator question. Let the calculator do the work for you, meaning you don't have to show a whole lot of work here. We're basically just showing that, hey, I'm going to find G of 6, and I've got a calculator. Now, since this is the very first thing we've done on this one, I'm assuming I'm probably going to need this in my calculator for more than one thing. So that means I'm going to come over here. I'm going to actually put it in the graph. Okay, so let me type in what this is. It was 0.35 X cubed, right? X cubed minus 3.5 X squared and plus 11. Okay, so I've graphed it, but I don't really care about what the graph looks like at this point. That's not really helping me any. What I want is I want G of 6. Well, I just put G in F1 in my calculator. So if I want G of 6, I can now come over here. I'm going to add the calculator part of it and just say I want F1 of 6. Boom, there's my answer, negative 39.4. Oops. So that means H of 1 equals negative 39.4. Or I could have just put over here equals negative 39.4. You don't necessarily have to write this part here. Okay? That right there, 1 point. All right, so the second part here says find all values of x for which f of x equals 4, or indicate that there are no such values. All right, so let's talk about how we present our answer here, because for some of you I wrote this might receive credit, not sure. Because some of you put it in ordered pairs, and I don't remember what the other things were, which what you put is correct. Like there was nothing crazy wrong with it. The problem is that I've seen some discussion in the groups that I'm in about, like, for example, just if it asks you for the x values or if it asks you for the zeros, like, what are you writing? And I don't know that these people are in the know or they're giving their opinions, but they are saying things like, well, I wouldn't give my students credit for that or whatever. So I want you to be safe here. It's asking me, so I'm going to write down f of x equals 4, because that's basically what it said. You don't have to write that part down. But then don't put it in an ordered pair, even if it's correct. They asked me for the values of x, so I'm going to say x equals. So, and I want all of them where f of x is equal to 4. Well, here's f of x, here's 4 here, and here. So here are my two x values, 2 and 5. So x equals 2 and 5. Or you can write it as x equals 2, x equals 5. Either one of those is fine. I did give you credit if you wrote it in ordered pairs. But be careful because do not don't do this, even if it's correct. F of 2 equals 4, and f of 5 equals 4. This is, again, this is correct, right? But I saw at least one person on the last one that we did try to write it like this, but get the x and the y backwards, so it is totally not worth it. They're only asking you for the x values, so this is what you want right here, okay? And then that is worth 1 point. All right, so then B says find all the values of x. So again, we're talking about values of x as a decimal approximation for which g of x equals 5, or indicate that there's no such values. All right, so I'm going to go here. Now I want g of x to equal 5. Okay, so I am going to write that down because I'm going to go get this in my calculator. Now I have g of x. Remember, we put it in F1. So when you want to know when this function equals 5, we're going to go back to the calculator. All right, and then I'm going to tab, and I'm going to, I don't know why mine flashes like that. I want to know when g of x equals 5, so tab to get to F2, now 5, stop the dancing, and it graphs this. Now be very, very careful here, because they did not give us any kind of domain restrictions. This is a cubic function, and I had quite a few people give me these two numbers, but not give me this one over here. So I'm looking for these intersections. Where does 5 intersect this function? So menu 4, no, I do not want that. Menu 6 for analyze graph. I want the intersection, so I'm going to start over here. And then, so I want that intersection there. Okay, so that is negative 1.235. So x equals negative 1.235. Then I'm going to go find the other one, or the second one rather. So menu, analyze graph, intersection. Put it on just that side of that one, other side over here. Now, it's hard to see it, and I have trouble grabbing this. Yeah, I can't grab this with my board. I'm not that talented at it. But you can grab it and you can move it so you can see. But that is 1.412. So 1.412. And then I've got that last one over there. And I can change my window if I want to. I don't know that I need to, so I'm not going to if I don't have to. Let me see what happens here. Menu 6, analyze graph, intersection again. That's fine there, but then I got to get on the other side of it. Oh, I can get there. Except it's not letting me enter. There we go. And so that is 9.822. 9.822. So there are 3 numbers there. There were, like I said, some people that just gave me these 2, which tells me you know exactly what you're doing. Just make sure that you really are finding all of them. One thing you could do if you're afraid of missing one, we could go to menu 4, and I'm going to zoom out. Now, when I do that, here's the important part. You see where it says center? I want my center to be at 0, 0. And then I can see that better. It makes the numbers actually kind of worse. But then you can see your graph a little bit better. Zoom out is not good for a lot of things. And also remember that if you zoom, so let's say that I hit over here. I said I wanted this to be my center, and then I zoomed out there, and like things got weird or whatever. Remember, you can go to 4, or menu 4, and then we can zoom standard, and it puts it back like it was. So you can like get out of it, so you don't have to start completely over. All right, so that is 1 point here for those 3. The second part says, determine the end behavior of G as X increases without bound. Express your answer using the mathematical notation of a limit. So there were a couple of people that did this correctly, but gave me, and let's make sure we pay attention to which one we're talking about, G. So the limit, I got this from a couple of people. X approaches negative infinity of G of X. equals, and the limit as x approaches infinity of g of x. I'm worried that even if these are correct, you may not get credit, because then you're not showing that you understand what increases without bound it means. This literally says determine the end behavior is x increases without bound. Express your answer using the mathematical notation of a limit. Okay, oops, go ahead and do that again. All right, which means I don't want that one. That's as x decreases without bound. This is as x increases without bound. All right, and again, this is a cubic, oh my gosh, okay. This is a cubic function, all right, and maybe you do need to zoom out so you can see it better. Let's zoom out again so we remember how to do this. For the center, you want your center at the origin, or really close to the origin, doesn't have to be exact. And you can even zoom out again if you need to. You can just kind of keep hitting that. But you know what a cubic looks like, okay? That's why we have 3 zeros. It intersects the x-axis 3 times here, right? And so the function looks like this. So as x gets bigger and bigger and bigger, so does y, so that is infinity. And that's worth 1 point. Y'all cleaned up your notation a lot. There were a couple of people, I made some notes like, you were like almost there and maybe you would get credit, but you know, I just don't know. And so we want to be very careful with how we write this. And actually, now that I'm looking at mine, let me write mine a little bit neater. So limit as x approaches infinity. Okay, so that x approaches infinity is of that of g of x, right under that, equals infinity. So that's a little bit better so you can see the notation better. Because the ones that weren't quite there, I don't think it had to do with handwriting or just being a little sloppy like mine was. Like that would be totally acceptable what I have there, but I want to make sure you know what it really looks like if you print it. All right, 1C. This says to determine if an inverse function of f can be constructed for all values of domain of f. Remember, this is just asking you, can it be constructed? Okay? Now, this is worded much better than the other one. Determine if an inverse function of f, meaning can an inverse, if I take the inverse, is that a function, that type of thing. So there's no reason to leave this blank. The answer is either an inverse function can be constructed or an inverse function cannot be constructed. You have a 50-50 shot here. Now, let's go back and look at what we have. So I'm going to go back over here. Let's look at our little table. All right, well, I've got this x value. I don't have any x values that repeat, so I know that this is a function. But look, I have these y values that repeat. So that means that, like if I were to, and you can also, you know, if you've got something like this, plot these points. Let's go to 1, 6. 1, 6, we'll do that. 2, 4, maybe right there. 3, 0, 4, negative 1, 5, 4, something like that, okay? And so this is a discrete function, so I don't, I'm not going to connect the dots. But if I did this, then I can see that I have these two that have repeating y's, and so it's going to fail the horizontal line test. Now remember, just saying that is not enough. But what we can say here is, and it says determine if an inverse function of f can be constructed. So I can just repeat what it says. An inverse function of f can be constructed for all values. Oh, can. I just said can. It is cannot. Good Lord. Sorry, I was worried about writing it. Cannot be constructed for all values in the domain of f. And it is said that way because, let's just talk about inverse functions real quick. Just a little side note here. I'm just going to do this. We know that if we have a parabola, right, it fails the horizontal line test. but if we restrict the domain, then we can take the inverse and get the square root function. So that's why there's words in here, all values in the domain. Because you can't for all values in the domain of a quadratic, because you can for some. So even for a quadratic, your answer would be no, but because it says all values in the domain. Now, the explanations here got much better, but some of you are trying to use too many words, or you're making a blanket statement that is not true. In order for me to be able to take a function and invert it and get another function, then I can't have any repeating inputs or outputs. But you cannot make the blanket statement that all functions have exactly one input for each output and exactly one output for each input, because that's not true. Not all functions do. They do if they're one-to-one, but not every single function. So that's where some of the issues were with your wording. So let's talk about what we can say in maybe the least amount of words, because if I don't think through what I'm going to write first, I just start writing and I end up having to write way too many words because I haven't organized my thoughts yet. Okay, so I think part of the problem was I knew what some of you were trying to get at, but you were referring to it or the function or, you got to take it out of your vocabulary. Or you were saying the function, but like which one? The one before you take the inverse or the one after you take the inverse? So, if I was able to ask you a couple leading questions, you could probably clarify that for me, but nobody's going to do that on these. You've got to make sure that you are clear to begin with. So the function that we have, okay, so what they gave us, f. So I can say, not that I have to say this, but I think this will help you organize your stuff out. So f is a function, because it does say, I didn't even read the question. It says, give a reason for your answer based on the definition of a function and the table of values for f of x. So f is a function because each input value has exactly one, or only one, but make sure you're clear there, it has exactly one output. Okay? So that's what makes it a function. So before I write this next step, let's think about this. So for a function, each input has exactly one output. So then in order for the inverse to be a function, each output has to have exactly one input, and that's not what's happening right here. This output has two different inputs. So you can say the inverse of f, so not f, but the inverse of f, oh, that looks terrible with all the f's in my handwriting. Inverse of f would not be a function because each output value, see, I'm just flipping it around, each output value does not have exactly one input value. And some of you went on to say things like, because at 4, like you were specific, that's fine. But let's read through this again. So f is a function. So f is a function because each input value has exactly one output. The inverse of f would not be a function because each output value does not have exactly one input value. And then again, if you wanted to give evidence and say because f of 2 and f of 5 are both 4, something like that. Okay. I think I stopped talking about grading here. That's 1 point for your correct explanation. You get 1 point for this, and you got a 50 shot, even if you were completely lost and confused. So hopefully on FRQ1, this was better than your last one, or at least not worse. And maybe even you've realized something you can improve on even more so that you can get even more points out of this the next time. Okay, let's look at FRQ 2. Alrighty, a group of students started a petition online in an attempt to push the start of the school day back 1 hour. 3 days after the petition, 3 days, oh my gosh. 3 days after the petition was posted, T equals 3, the petition had received 4,000 signatures. After 7 days online, T equals 7, the petition had received 23,000 signatures. The number of signatures the online petition has received can be modeled by this function, okay, where S of T is the number of signatures in thousands. You have to pay attention to that. After day T, T is the number of days since the petition was posted online. So here's what I know right now. I know that I have an ordered pair that's 3. So it's 3 had 4,000, but it's 4 because it's in thousands. And 7, 23. The first part says use the given data to write. All we're doing is writing 2 equations that can be used to find the values for the constants A and B in the expression for S of T. Okay, so here we are. So I'm going to write down this so that we can refer back to it. They told me that S of T, so I'm putting it up here because this is not actually part of my answer. S of T is equal to A times B to the T power. Okay. So I know I had that ordered pair, which was 3, 4, which means S of T, which is 4, is equal to A times B to the 3rd power. And then I had 23 equals A times B to the 7th. I literally just took the information they gave me and put it in here. Those 2 equations right there, 1 point. Remember, this is right to the equation. You're not figuring anything out right now. We just wrote them down. There were a couple of people that had S of S of 3 equals A times B to the 3rd, and S of 7 equals A times B to the 7th. Now, those are true statements. It doesn't have as much information as it does over here, so I don't know if you would get credit for that or not. Just put in your X and Y. Okay, whatever they give you, you put it in X and a Y, and you stop, and there are your equations. Okay. All right. The second part says find the values for A and B as decimal approximation. Again, it does not tell me to write an equation. It asks for A and it asks for B. So I'm not going to write an equation because then if I do that, if I do it and I do it correctly, all fine and great. If I do it and I do it wrong, that's a problem. So I got A and B. Can I do this by hand? Yes. Is this a calculator question? Yes. Therefore, I'm going to use the calculator. So I'm going to come over here on, I want new. No, I don't want to save. And so here, I'm going to do a regression because I'm trying to figure out what those are. So that means I'm going to choose 4. Here and put X. My X values were 3 and 7. And then my Y values were 4 and 23. I think, let me double check my paper. Make sure I didn't put those backwards. Okay. All right, so now I want to do regression. Menu, statistics, stat calculations, and they gave me this right here. This is exponential, so that's how I know what to choose. I see here, I'm choosing exponential, which is A. Do my thing. Once you get this stuff in here and y'all choose the right one, you're good at this stuff. Here's one thing you need to check, though, okay? Because we're going to look at a couple of these that even though it's a calculator question, sometimes you have to do stuff by hand. Make sure that that whatever this is right here in this box, oh my gosh, whatever that equation is right there in that box, that it actually matches the generic one that they gave you. Because if they had given you, if they said do it as like A times B to the X plus 1, okay, then this is not your answer, so you have to be really careful with what you're doing. And we'll look at that in class together. But so my A is 1.077. Oops. 1.077, and my B is 1.548. Okay, so here's the deal. You get 1 point for A and B. Now, what some people did is here, instead of having 4 and 23, they had 4,000 and 23,000, which meant they did not get this point. However, if they used their wrong answers correctly, this would have been 1,077, and they got that point. Okay, that should be the way that this is graded, but, you know, we'll all figure it out in the end, I guess. Okay, B. So B says, use the given data to find the average rate of change, the number of signatures in thousands, it tells you again, of signatures per day from t equals 3 to t equals 7 days. Okay? Average rate of change. This is slope. Don't miss a slope question. Oh my gosh. Okay, so here we go. And we're going from 3 to 7. So that means, now remember, we want to write it like this so that we don't mess it up and get it in the wrong order. I want S of 7 minus S of 3 over 7 minus 3. Okay. Then I substitute in what S of 7 is. That is 23 minus 4 over 7 minus 3. This is a calculator question. Use the calculator. So here, I'm going to add the actual calculator. And I'm going to do, I'm going to do 23, 23 minus 4 over 7 minus 3. 4.75. So this is 4.75. And, you know, I feel like, as far as the grading is concerned, some of you didn't get the first part here at all, where you write your equations, okay? You just didn't get this point. Then you got this in the thousands and the other one in the thousands. I think they would use your wrong answer to kind of give you credit along the way, but if you didn't really show where it came from, I don't know. The other thing is, some of you had the wrong thing here, but then ended up with 4.75 here, and so, because maybe you kind of figured out that it was in thousands or whatever, because that stuff didn't jive, I don't know if you would get this point then or not. But you do get it if it's 4.75 and you have everything else that matches. All right. Then the next part says, use the average rate of change in the one above it to estimate the number of signatures in thousands online petition receives after t equals 13 days. So remember, you have a couple of different ways that you can do this. We can write an equation for a line, okay? Not sure how everybody feels about that, but y minus, so I'm going to use the ordered pair. Might as well just use 723 because the calculator's going to do it for me anyway. I'm just going to use the first one. So y minus 23 equals the slope times x minus 7. And I want to know what it is for 13, so that would be y equals 4.75 times 13 minus 7 plus 23. And I can let the calculator do that for me as well. So 4.75 times, I already forgot what it was, 13 minus 7. Close my parentheses, plus 23. You get 51.5. Okay, so another way to do it is using the slope, leaving the 23 and the 7 there, so 23 minus something over 7 minus something, and I want to know, I want to use the 13, right, where t is 13, so this is 13, this is the y that I don't know, and this is equal to 4.75. So if I take 4.75, multiply it by that, and do everything else I need to do, I still get y equals 51.5. Which, now that I think about it, quite a few people got the right answer, but I wasn't really paying attention to which one of those you chose, so, but y'all did do well on that. Okay. Now, the Roman numeral, the little 3 part here. Says, consider the average rates of change of S from t equals 7 to t equals p days, where p is greater than 7. Are these average rates of change? So we're considering from t equals 7 to t equals p, meaning that, bigger than what we have here, where p is greater than 7. Are these average rates of change less than or greater than the average rate of change from t equals 3 to t equals 7? Explain your reasoning. Now, this is an exponential. There were lots of explanations about it being an exponential, but the problem is that's not really showing that you understand how to answer the question, even if you didn't know what it looked like. Now, we do have to have an idea of what it looks like, and we can look at it because we're here. We have a calculator here. We have this, but I don't have the graph yet, so I want to add a page. I'm going to add a graph. And remember, I'd already put it in F1 for me, so I just have to hit enter, and there we go. Because I know what an exponential looks like, but it could be growth or decay. I think we know what it is, but again, just look at it to make sure you know. So we know that it is exponential growth. It looks like this. So you can't just say because it keeps on getting bigger. Well, yeah, the numbers keep on getting bigger. That doesn't have anything to do with the rates of change, because I could be getting bigger. My y values are getting bigger, but my rate of change is the same, so it doesn't change. What we see here is that this is concave up, so we use our fun chart. And we know that it's asking if the average rates of change are going to be bigger or smaller. Well, this is concave up, which means my rates of change are increasing. So I'm going to use the words from the question here. It says, consider the average rates of change. Okay. So I'm going to say the average rates of change of S from t equals 7 to t equals p days will be greater. Oh, can't spell. Greater than the average rates of change from t equals 3 to t equals 7 days, because S is concave up, therefore rates of change of S are increasing. Okay? Don't say it. Don't say because it is concave up. What is concave up? I had a few people write the average rates of change were concave up. I didn't even know what that means. Average rates of change can't be concave up. They're numbers. Okay, so they're either increasing or they're decreasing or they're positive or they're negative, but concave up makes absolutely no sense. So make sure that you're using, reread this and make sure what you wrote actually makes sense and that you're using your fun chart. All right, 2C. For which t value, t equals 6 or t equals 19 days, should the students have more confidence when using the model? Give a reason for your answer in the context of the problem. Okay, so I will give you this. Even those of you that didn't get the point, you were really trying hard for the context of the problem, that sort of thing, but not in the right way. The context of the problem, but you still have to give like a mathematical reason, okay? So we would say that students should have more confidence in t equals 6 days when using the model S, model for S, because now, and I will tell you this too, some of you found what it was at 6 and you found what it was at 19, and we're like, well, the 19 doesn't really make any sense. And there were some of your explanations that I didn't give credit for that, who knows, maybe you would get credit for. I just don't think so, and I don't know for sure. But the reason that t equals 6 days we would have more confidence in and it would be more accurate of a prediction is not just because it's smaller, but because t equals 6 falls between the given data t equals 3 and t equals 7 days. Okay. And, I think I stopped talking about grading. So this is one, everything here is just split up with 1 point, 1 point, 1 point. 1 point for that explanation, 1 point for that. Okay? Alrighty. Remember, you can come to map time if you have questions on any of these, and we can look at them, if you have extra questions about this. But please go through all of this first. On to FRQ 3. Now, I will say, quite a few of you have figured out how a y-axis works. And there were less really weird off-the-wall labeling of the points, but there were still some of you that you don't understand the y-axis thing. You need to get somebody else to explain it to you, because clearly it's not working for you. Okay, so let's read what this says. Now remember, we take some time to make sense of this before we worry about trying to do anything. So Mr. Passwater's wife wanted him to purchase a Roomba that would vacuum his living room automatically each day. However, he found a deal on the internet and purchased a Roomba instead. The Roomba does not operate properly and travels only in a circular path, completing 1 rotation every 15 seconds. Here is the Roomba. It goes around like this. It's going to take 15 seconds to get all the way around. You know what that tells me? It tells me that my period is 15 seconds. 1 rotation. Point B is right up here, the edge of the Roomba, and is located directly above the center of the circular path at t equals 0. No, sorry, I'm worried about my point here. T equals 0 seconds, as indicated in the figure. Point B is 5 feet from the center of the circular path and 1 foot from the wall. So this is 5, this is 1, which means this here is also 5 because it's a circle, and that's the way circles work, and it said center, which means from here to here, this whole distance has to be 11. So the closest it's going to get to the wall is going to be 1 away. The farthest it's going to be from the wall, it'll be 11 feet away. Okay. As the Roomba travels at a constant speed, the distance between B and the wall or periodically increases and decreases. So it starts here at 0. So at 0, we are 1 foot away. Also, since it takes 15 seconds, at 15 seconds, we are 1 foot away. Think about that. This is at 0. This is at 15, 30, 45, every 15 seconds. So halfway between the two, when Roomba is here, that would be halfway. I'm sorry, that's not halfway. This is halfway around. This is halfway around. So halfway around, okay, I am now 11 feet away, but that's halfway through my time, so that is 7.5, and I would be 11 feet away. Here, halfway between the 0 seconds or minutes, what are these? Seconds. Halfway between the 0 and the 15 seconds was 7.5, so this is halfway between 0 and 7.5, which is 3.75. That would make this 6 feet away. Okay, you could have left these as fractions, 15 over 2, 11, and 15 over 4, 11. That is fine also. But some of y'all can't do fractions or decimals, so I'm at a loss. I don't know. All right, so the sinusoidal function h models the distance between B and the wall in feet. All right, so we are going to plot these points. Okay? I'm going to do my y-axis first. Remember, this is there's a y-axis here. Like, we can't draw it in because I don't know where 0 is on my x-axis. But let's just, for pretend's sake, say it was right here. And I'm going to erase this. My numbers on my y-axis go from least to greatest. Okay? So that means that whatever number I put here has to be the smallest of my 3 y values. Okay? The closest this thing gets to the wall is 1 foot. Then my number should get bigger as I go up. The farthest this thing gets from the wall is 11 feet. I can repeat y values. I cannot repeat x values. Then when halfway through my time, that was where we were at 6 feet. So I've got those. Now, I know from what I wrote over here that at 0, I'm 1 foot away. Okay, so 0, 1 is an ordered pair. So when I go back over here, I can't put a 0 here because then I would have negative time. So I'm going to continue my graph like this. This is still 1. This would also be 6. Like, nobody asked me for those, but those help me, so I'm writing them down. Here's my 0, 1. I know that it's going to take 15 seconds for me to get back to being 1 foot away. So this is 15. Which makes this 7.5, because that's half of that, makes this 3.75. And then this is a non-calculator question. So again, you got to decide. Fractions or decimals. I mean, to me, the fractions are actually easier, but whatever. I mean, I can take 3.75 and add it to 7.5. That would be 10, 11.25. And then I would take 3. So basically, each little section here is 3.75 seconds away, because if I add 3.75 to that, I get 15. This gives me 18.75. I add 3 more to that, that's going to be what, 22.5? 22.5. There are my points. My X's, my green ones going from left to right, get bigger, and my pink ones going from bottom to top go from least to greatest. Okay? So this is worth 2 points. 1 for your X values, 1 for your Y values. We all need to say a little prayer about FRQ 3, I think. Well, 4 also, but yikesies. Just getting if you can't get these points labeled, it hinders everything else that you do. Now, even though B is on the next part of your booklet, I'm going to stay here so that we can look at these numbers here. So this says, let's go back here and read this. So we did this part. Now it says, now we're on part B. The function h can be written, okay, so we're using a cosine again. Pay attention, because you don't get to decide if it's sine or cosine, right? That decision is already made for you. So I'm going to write the generic one here. What do they call it? H of t. Okay. So h of t is equal to a times the cosine of b times t plus c plus d, right? And I got to figure out A, B, and C. And I got more than one option here, just like we did the other day. It's cosine, so I can start here and end here, or I can start here and end here. Okay? Most of you did this to this, but I did have a couple of people do the other, so we will look at both of them. So I got to figure out A. A is the amplitude. Okay? It is the distance excuse me, from the midline to the max or min. That is excuse me, that is a vertical stretch or compression. That affects the y values. So I'm looking at the y values when I do that. From 6 to 11, that is 5. Don't use your x values. We don't care about that right now. B, this is cosine. So to find b, that is 2 pi divided by the period. Well, we already decided over here, right, that since it takes one rotation every 15 seconds, my period is 15 seconds. So that means that this is 2 pi divided by 15, which we can't reduce. So that's it. C is where I shift left or right. So I know that cosine normally starts on the y-axis, but I'm starting here at 7.5, which means I moved to the right 7.5. So I'm going to, I would say this is t minus 7.5, if I was to put it in this equation right here, because x is a liar, so this means I go to the right. Based on what they have here, that means C is negative 7.5. On the mock, they would have taken the positive 7.5. I don't know if they will in the real thing. Maybe. D is your midline. It is a y value. It is 6. Okay. Now let's look at the other way. Or, let's say we start here and we end here. That changes A. It's still 5, but that makes it negative because there's a reflection. The period stays the same. But since the x value is 0, we're actually starting on the y-axis. So I don't shift left or right. So C is equal to 0, and D is the same also, which is 6. Okay. So let's go put these over here. We had 5, 2 pi over 15, negative 7.5, and 6. The way these points work is you get 1 point for the y transformations and 1 point for the x transformations, or 1 point for the horizontal and the vertical. So that is 1-1. Unfortunately, some of you got like A and B right, but then missed C and D, and you're not going to get any points for that. Okay? But really, guys, these two things here, if you get the numbers on there, it should be a piece of cake. But I don't know how else to explain how to put the numbers on there. I just don't. Okay. Now, 3C says, says on the interval from T1 to T2, which of the following is true about H? Okay, so let's figure out T1 to T2. It's telling you we're going from G to J. So let me go back over here and let's look at this. Going from G to J. From G to J right here. And this is strictly talking about the function, H. Nothing about the rate of change. The function, which means the fun chart isn't going to do anything for you but confuse you. We only need that when we're talking about rates. The function itself. From here to here, the y values are getting smaller, so the function is decreasing. And the function, this is going from 6 to 1, they're all positive numbers, so it is decreasing and positive, or positive and decreasing, which is B. Oops, clicked the wrong thing. And so remember, all I want you to do is put B. That's it. All right, then it says describe how the rate of change is changing. How is the rate of change changing? Well, this is what it looked like from G to J, right? Here our fun chart is going to help us because it is asking for the rate of change. Now, let me remind you, when we've asked this question, we normally talk about both things, like is it increasing or decreasing and is it positive or negative? All this asked was, how is it changing? How is it changing is increasing and decreasing. It has nothing to do with this. So we're not even going to talk about this. Don't even care. Because I don't want you to get this part right and that part wrong, or some of y'all get your explanations. I don't know what the heck is happening. But this is the only part we're looking at. So now, if the question asks you for positive or negative, absolutely put it there. But, and maybe we will say what it is. But since the function, let's just go ahead. The function itself is decreasing, which means the rate of change is negative. Okay? Because if you give me the right thing and then say it's positive, you're totally wrong. But what we know here is the function is concave up, which means the rate of change is increasing. So again, take the word it and get it out of your vocabulary. We're going to say the rate, or just the rate of change of H is, we just decided, increasing on T1 to T2 because, not it, don't say it, because H is concave up on T1 to T2. And there you go. Oh, and I lost all the points again. I keep forgetting to put them on here. So you get 1 for it's increasing Y. You get 1 for B. We already talked about the 1-1 here. So I did see much improvement on this, but I don't know, still a little questionable. All right, so let's look at FRQ 4. Oops. Here we go. So we won't talk about the instructions again. Here's what they give us. On A1, it says solve g of x equals 27. So I'm going to set this equal to 27 over here. And that's going to give me 3 to the 2x power times 3 to the x plus 4 power equals 27. All right. You have to know your exponent rules. Plain and simple. You have to know them. I don't know what to tell you. They are absolutely not brand new. You start learning them in Algebra 1. And I know for a fact, if I asked you x squared times x cubed, you would all be able to tell me it is x to the 5th. It is not x to the 6th. That is because that is x to the 2 plus 3 power, because you add the exponents when you multiply. So here, we are multiplying these. The base is still 3. You add the exponents. So 2x plus x is 3x plus 4. That is your exponent. Now, it's equal to 27. Sure, I could do logs and stuff here, but I don't have a calculator, and I don't think this is going to work out too well for me by hand. But I can change 27 to a base of 3 to some power. And 27 is 3 to the 3rd power. Now that I have one exponential on each side, the bases are the same. I can drop the bases. I get 3x plus 4 equals 3. 3x equals negative 1. X equals negative 1/3. That is 100% an Algebra 2 question. 100%. I was even talking to the Algebra 2 teachers today at lunch. 100% an Algebra 2 question. You've done it in Algebra 2. We redid it quite a bit this year. You have got to know those power rules, and don't be multiplying this. That's why your number's coming out weird, because you're making up math. All right. The second part says to solve h of x for 5. So h of x is, okay, I just got interrupted and had to pause, so I don't know what the last thing I said was, but we're going to take h of x and set it equal to 5. So 2 tangent squared x minus 1 equals 5. All right, so solving for x, which means I got to get tangent of x by itself first. So the first thing I'm going to do, basic solving equations, add 1 to both sides. 2 tangent squared x equals 6. Then I divide. So tangent squared x equals 3. So how do I undo a square? Take the square root. And for the love of God and all that is holy, when you take the square root, you have to put plus or minus. Plus or minus. I don't know how else to say that either. I just don't know. So tangent of x is equal to plus or minus the square root of 3. Then we have to pay attention to what else this says. It says, solve for h of x for all values of x on this interval from 0 to 2 pi. So I'm looking from 0 to 2 pi. Okay? which means that, well, since this is plus or minus, I need the answer from all 4 quadrants. So x equals, well, square root of 3, tangent would give me pi thirds. Then my second quadrant pi thirds is 2 pi thirds. Then 4 pi thirds. Then 5 pi thirds. And there you go. Plus or minus? Plus or minus. Okay, oh, points here. 1 point for this one. 1 point for this one. All right. Then we're on to B. We've got J and K. Now, some of y'all broke my heart. Y'all all promised me that we were not going to miss a question like this. You promised me. And then you broke my heart. So let's do this one more time. I'm going to write down what it is. You wouldn't necessarily have to do this, but J of x equals 2 times log base 10 of x plus 3 minus log base 10 of x minus log base 10 of 3. Okie dokie. So before we start combining anything, we look at these logs. In front of the word log, there's a 2. This guy becomes an exponent, and then he disappears from here. In front of this word log, nothing. In front of this word log, nothing. Now I'm ready to put things together. So I can say j of x equals log base 10. Okay, now look. I think I said the other day, I can't believe that they would actually put the 10 on there, but they are. Now, if you leave it off, that's still the common log and you're fine. And I think you would get credit either way, but let's just go with if they put a base on there, you just leave the base on there. Then I have some minuses, so I'm going to make a fraction. Now look, everything that is positive, this is positive. Therefore, this part goes in the numerator. X plus 3 squared. Squared. This is negative. Therefore, this goes in the denominator. This is negative. Therefore, this goes in the denominator. But it is not x minus 3. It's x times 3. And there were some of you that, and you can just leave it just like that. You can put 3x and that's fine too. There were some of you that had like a multiplication symbol right there, like a dot, which is fine. But there was a couple people I wrote like, is that a dot or is that a minus sign? I don't know. Because there were also a lot of people that straight up had x minus 3 in the denominator. I don't know where the heck you got that mess. But everything's being multiplied and you just put it where it goes and you stop. Don't miss that part of the question. You can do this. I know you can. All right. 1. So now we are going, then it says rewrite k of x is a fraction only involving secant of x and no other trigonometric functions. All right, so I'm going to rewrite this over here. So I've got k of x equals tangent squared x times cotangent x over cosecant x. Okay, so what we're going for here is just secants, okay? So I'm going to write this over here so I don't forget what my goal is. Secant x. All right, so I know I could change tangent to sine over cosine, but since secant is my goal, I don't know that I want to put sine and cosine in here. I think I want to keep the secants and the cosecants and the tangents. And I know that I have these Pythagorean identities where maybe you are sure, maybe you're not sure. Pretty sure that tangent squared and secant squared kind of go hand in hand there. So let's see what we can do with that. So here's the thing. Like, I know mine, but I know that you don't just straight up know yours. One of the ones that you have to straight up know is sine squared theta plus cosine squared theta equals 1. All right, now we're trying to get to secants, right? The reciprocal of secant is cosine. So if I divide this by cosine squared theta, that'll give me secant squared. So that means I divide each one of these by cosine squared theta. Well, this right here gives me tangent squared theta. This gives me 1, and this gives me secant squared theta. So when I look over here at something to substitute in, instead of tangent squared right here, I could do secant squared minus 1, right? Because I can subtract that over. So that means I'm going to get secant squared x minus 1. And then cotangent. Now, I'm going to separate all this stuff out, okay? Meaning that I'm going to do secant squared over 1, because I can do all this separate, times, well, cotangent is really just a cosine over sine. So cosine x over sine x times 1 over cosecant x. Okay? So if I do this, now these two are reciprocals of each other, so they just cancel out to give me 1. So now I'm left with secant squared x minus 1 times cosine x. But remember, I want it all in secants. Well, the reciprocal of cosine is secant, so I can make this into secant squared x minus 1 over secant x, and I'm done. And that right there is worth 1 point. Did I give you the point up here? Yeah, that was worth 1 point. All right, now, FRQ4 C part, this is going to be a challenging part. That does not mean to not even try it, okay? But what that does mean is that, if you only have time left to go back and do something else, maybe your time is better spent that way. But it also means don't get into this and get so frustrated and start beating yourself up because you can't get through it. It's not the end of the world. Try it. Maybe you can get part of it. Who knows? Well, sometimes things just work out. So, function m is given by 2 to the 5x plus 3 power over 2 to the x minus 2 to the 3rd power. And we want to find all the input values in the domain of m that yield an output value of 1/16. So I need to set that equal to 1/16. Okay? All right. So let's talk exponent rules, okay? Because that's all this is. Basic exponent rules, taking it a step at a time, not making up math, all right? So here, I'm going to rewrite my numerator, 5x plus 3 power over, now, this is a power to a power. This is where you multiply. So I'm going to distribute that 3, and I'm going to get 2 to the 3x minus 6 power. And that's going to equal, now, I could put 1/16 again, but I'm dealing with exponents here. My base is 2. I think I kind of need to get a base of 2 over here. So if I leave this as a fraction, 1 over, we'll put a 2 there. 2 to the 4th power is 16. So I got that so far. Okay? And I can basically at this point, there's a couple of different ways we could go about this. I could make that into a negative exponent. I think that I might want to do that. So I could cross multiply. There's a few things I could do. Sorry, I'm just sort of thinking out loud, which is the best way to show you. So we know that let's just take a little side note here. I'll tell you about a couple of different ways we could do this. I know if I have a to the m times a to the n, that is a to the m plus n power, okay, because you add the exponents. If I have a to the m over a to the, well, why am I writing it over there? A to the m over a to the n power, and that's equal to a to the m minus n power. So I could, okay, options here, I could leave my bases 2, subtract these two sets of exponents. But I'm a little worried about y'all not distributing your signs and stuff correctly. So I think what I want to do is move over here. I'm going to rewrite, actually, instead of doing that. I've already written this, so I'm just going to kind of mark that out, and I'm going to change it to 2 to the negative 4th power, which is the same thing, right? I just kind of changed my mind, want to do that. That's totally acceptable. So now that I have that, I want to get rid of this denominator. So my numerator here is 2 to the 5x plus 3 power. That's equal to 2 to the negative 4th power times, because if I multiply both sides by this is like this over 1. So I'm going to multiply this over here, 2 to the 3x minus 6 power. Okay? Because I'm multiplying it. This would have become a negative exponent if I left it on this side, but because I'm multiplying it over there, it's different. It's just like if I had x over 5 equals 3, right? Just multiply both sides by 5. That's basically what I did right here. All right, so now, can't drop my 2's. My left-hand side stays the same. 2 to the 5x plus 3 power equals. Now remember, when you multiply the same bases, you add the exponents. So this is 3x, so this is basis 2, 3x minus 6 minus 4, so this is 3x minus 10. Now that I have congruent bases, 1 on each side, I can drop the 2's, and I get 5x plus 3 equals 3x minus 10. So 2x equals a negative 13. X equals negative 13 over 2. All right, you got 2 points here. One of them is for getting this far. Being able to know this rule and change this to a common base. And whether you have it like this or like this, it doesn't matter. That's 1 point there. Then when you keep going and you get this answer, that's another point. And there you go. There's your 6 points. Okay? To me, this one, for what you have in your brain and what road you're going to go down, I think that is way more doable than that one that we had was a quadratic, because I just don't think most of you would have thought to do that. But you have these exponent rule skills. I know you do. So don't overthink it. Don't stress yourself out. You can do this. You can do hard things. Okay?